So here we have a scatter plot, and we're going to have a look at how we can describe the relationship and how we can determine the equation of the line of best fit. So first of all, we need to understand what the variables and the units are that we're describing. So let's have a look. We've got age in years and price in dollars, and the title tells us it's the price of used motorcycles. So therefore, on our independent axis, which is usually X, so our independent variable is the age of the motorcycle, and our dependent variable, which is the standard Y axis, is the price of those motorcycles in dollars. Now it asks us to describe the relationship between the variables. So if we have a look at each axis, we can see that as the motorcycle is getting older, the price is going down. So I've written that in two different ways. The older the motorcycle is, the lower the price, or as the motorcycle increases in age, it decreases in price. In order to analyse the relationship or the trend further, we need to put in a line of best fit. Now a line of best fit should roughly go through the middle of all your dots. Once we have a line of best fit, we can analyse it a little bit further. This asks which motorcycle in the dataset would be predicted furthest from the actual value. So furthest from the value that's given, so the value that is the scatter plot, from the line that we have made as our prediction. And as we can see, that's this one here, because it's the furthest away from the line. It should, according to our line, be here, but it's not. So this actual value is the furthest from our predicted line. You could argue that that's an outlier. So that's the 10-year-old motorcycle for $4,000, and you can argue that's an outlier because it's the furthest from the trend of the rest of the points. According to our trend line, what would the price of a 10-year-old motorcycle be? So if we go to 10 years down here and follow it up, we pass the point we had in our data and we get all the way up here. So according to our trend line, a 10-year-old motorcycle should be $9,000, not $4,000. Now you're going to want to find the equation of your line. So remember, y equals mx plus b, where m is your slope or gradient and b is your y-intercept. Now, we don't have a y-intercept on this graph, so we're not going to be able to just simply substitute into that equation. We can, however, find our slope using 2 points. Remember that our slope is equal to our difference in y divided by our difference in x, otherwise referred to as our rise divided by our run. You can choose any 2 points for your slope. I'm going to choose this one here, which is 3/16,000. And I've just got to find another one that is at a corner of a grid line, so it's an actual point on the grid. And that my line goes through evenly, exactly at point, so I could choose anything I like. So let's try and keep the difference nice and small. Let's go to 6 here and 13,000. So the 2 points I'm using are 3 and 16,000 and 6 and 13,000. So now you could draw a triangle there. You can see that your rise here is 3,000 or negative 3,000 as it's going down from 16,000 to 13,000. And your run goes from 3 to 6, so that's 3. So your slope is negative 1,000. So I can put that into my equation, y equals negative 1,000x plus b, and then I can substitute one of my values to find b. I've used y and x as they are the variables in the general equation. We obviously have age and price. But age is my independent, so that's going to be my x, and price is my dependent, so I'm going to substitute that for y. I'm going to substitute this point here, which is 3 and 16,000. But you can substitute any point you like. So I'm going to replace x is 3 where x is, and 16,000 where y is, so that I can find my b value. So let's do that. So 16,000 is equal to negative 1,000 times 3 plus b, which is 16,000 equals negative 3,000 plus b. Now this is a negative 3,000, so to move it to the other side, I'm going to have to add 3,000. So after adding 3,000, we get 19,000 equals b. So now we just substitute both values in. Remember, y equals mx. We know that m is negative 1,000. We always put the x next to it, and we know that b is 19,000. And if you wanted to change your variables to be more appropriate to your scenario, you could say p equals negative 1,000 a plus 19,000. So you have p for price, a for age in years, which matches your two axes. And that's how we find a line of best fit and the equation to go with it.